right. The announcement, any moment. All right, I think let's wait a few minutes and we'll start. Let's clean up it in the meanwhile. Oof, I didn't want to close all documents. Yes. Okay. Let's wait a few more minutes and we'll start. Today I'll try to talk about why do we need interfaces? What's this all about? Dependency inversion principle? What's inversion of control? How can we achieve it? How do we use containers? I'll try to compare different containers, 3 in fact, and I'll try to see how this works in a generic repository design and in clean architecture, where you can freely make choices independent of lower implementations, lower level implementations. So let's wait a few more minutes and we will start. Hello, Jonathan. So this is the third lesson of object-oriented programming, and this is probably going at a bit bigger pace than intended, as I'm talking about topics that are not so basic right now. Well, the thing about inversion of control, it's nothing too complex, it's nothing advanced. It's just something that you need to realize and be aware of to understand that it exists and you can use it. And it simplifies the way you can work with programs, with designing your dependencies, with managing them. So, still not sure if I should start already or not. I see 5 people tuned in. Did anyone write anything? Okay. Okay, I will start. Well, first off, what is dependency inversion principle? If I look at my structure, you see I have application, enums, IoC, models, and repository. Enums and IoC is a bit not standard in terms of what you see in folder structure. And those are normally application, models, and repository are separate projects, but for simplicity's sake, I just made them different namespaces. So anyways, if you look at school terminal, it's basically a class which is supposed to print some information about school, the teachers, students, grades, and lessons within that school. Pretty straightforward thing, and it has no logic other than fetching stuff from somewhere. And the thing about the school terminal is that even though this school specific terminal depends on those repositories, it doesn't have to depend on those repositories. Because I have school terminal, and all I know that school terminal does, it prints info about the school. That's all. And so if I wanted, I could implement a broken, let's say, school terminal, which prints hard-coded string. And I'll do it right now. So if I say iSchoolTerminal, I make it public because interface, and I say implement, and then I say broken. So right now I made a different implementation which conforms to an existing interface. iSchoolTerminal had to print info. And here I implement how I print info. Now it's iSchoolTerminal, and you might think, why is it iSchoolTerminal? What's in it for me, for iSchoolTerminal? Why can't it be just terminal? Because, well, for now, it's not so clear. And if I go to program, I have app. App is actually iSchoolTerminal. And so I don't need this right now. So dependency inversion principle basically states that high-level modules should not depend on low-level modules. Both should depend on abstractions. High-level module is program. High-level module is terminal, but it's slightly lower module. Now, if we look at the terminal, at the specific terminal, we have, I should rename it. We have a whole bunch of components. And if I had something like this instead of interfaces, that would mean my school terminal depends on details, on repositories that are implemented. So if I didn't have a terminal which held dependencies through interfaces, I would have details as dependencies. Now that I have interface-based dependencies, they're abstractions, and they can be swapped. And how do I swap them, and why is it important? It's important because here I do dependency injection. By making this right here, I say that each component within this school terminal can be swapped, changed, and it will still work. And I will not change the internals. What I need from school terminal is to just get all info and print it. That's what I do here. And the thing about it is that I shouldn't care how I get info. And in fact, I should probably not even care how I print stuff either. I should just know that I can print all entities in some way, some generic way. That's all. But for simplicity's sake, let's limit ourselves to just repository. So repository can get data from some data source, and it can be a file, it can be a database, it can be in-memory stuff, it doesn't matter. it's a detail of implementation, and we don't want to think about details too much. We want to think about abstractions because we know what we need to do, but we don't really have to know how. So if I go to student repository, it is implementing a generic repository, but let's get back to it a bit later. So I have iSchool terminal, and that's my app. And well, that's a concrete terminal, but now I need to, that's an abstraction. So now I need to create it, and now I need to make a detail out of abstraction. Hello, Joshmont. So I need to pick, which detail do I pick? Do I pick school terminal, the good one, or broken one? So if I choose this instead and run, you will see that it just prints broken because within it, it's broken. And the thing about this is that now I don't really need to change the definition for it, and I could just say a different kind of terminal, school terminal. But the problem is that I have a bunch of dependencies coming with school terminal, and I need to somehow inject them. With normal terminal, with broken terminal, it had no dependencies. And this is barely a dependency injection. This is just hard coding a dependency inside a function. This has nothing to do with dependency inversion principle. However, this one does. It is a console app, yes, Groony. It's a demo how you can use dependency injection and dependency inversion principle and inversion of control container to manage your dependencies and manage your repository. So here I have school terminal, and I'll make it here, and I say no dip, no DE. So no DE looks like this. Broken terminal. This is no dependency injection. Now with dependency injection, we have this. I'll just name this app 1, app 2. So we would need to inject all the dependencies. So this is not broken school terminal, but this is school terminal. And so we need to inject students repository with some context, and we need to create that context now. So it's a bit complicated, and you'll see why it will be quite tedious quite fast. So to make that work, I need to create context. The context is here. School memory context. Oops. New school memory context. And I need to feed this, this. Then I need to do the same with teachers repository, where I pass in the context. Then I need to do the same with the grades repository, where I pass in the context. And then I need to do the same with lesson class repository, where I pass in the context as well. And you can see how already it became quite ugly to create. Like, I had to make 2 lines, well, almost 3, just to create something. And it's ugly. So inversion of control handles this by simplifying the process of creating dependencies. And you can do them little by little. Teacher's repository. Okay. But anyways, in order to execute a program, we now need to instantiate all the dependencies by ourselves. What if this one had a dependency of its own, and it does, the context? What if it had different dependencies, or maybe different instances of dependencies that need to be created? It becomes harder and harder. Teacher repository, I'm using different one. It should be in memory. All should be in memory. Okay. So yep. So it's fine for personal projects. It's fine for simple projects, for small projects. And probably this example, what I did in a few hours, will not illustrate the greatness of IoC container. And I personally don't love it myself. But as you mentioned here, IoC is dedicated for inverting the flow of control. And the flow of control normally is that if you need to use some component, some class, like here, school terminal, you need to create dependencies for it. And the flow of control is inverted as it is done in the highest level of application once, and you no longer need to keep creating them or keep passing stuff. It just happens. So this is no dependency injection. This is dependency injection, no inversion of control. And this is with dependency injection and with inversion of control. Yes. That's true. And yeah, and but you still, but it still keeps recreating them, or it keeps and creates it once. You can still do it. About the DB context. And what I have here is not actual context, it's in-memory stuff. But anyways, till you manage to answer or not, I will continue. So, how does dependency injection, dependency injection through IoC happens? In .NET, we have several dependency injection containers, and the default one, I think, is Unity. The oldest one probably too. So we have Unity, Autofact, Inject, something Castle, and a few others. But those three are the most popular ones. But the thing is, just like testing, you need to get a hang of the concept. When you get the concept, you will understand the use of it. So what do? In Unity, you basically say that this interface will become this type, and this type will become this type, So you basically register every abstraction to a specific implementation. The thing on the left gets implemented by the thing on the right. And so you register it, and in the end, after you registered everything, you say resolve, and the magic happens here. Remember how we defined school terminal? We said that all the dependencies come through a constructor. And here, it basically does the magic and resolves those dependencies that we registered up here. One misconception that I had before this lesson and in general about IoC containers, I thought that they're very much like service locators, where you basically say that this container has to be static, and then Unity container, and then you say container, and then you say instead of that, this, and so on, and then later on, where you need it to call this. Well, that's not true. You don't want to have a service locator like Unity container or any other IoC container, simply because it's supposed to happen once in your application. Some place in the highest level once you register the dependencies, and that's good enough. So, Judgment asked, would pooling the context make that more efficient, easier to work with? Well, usually you work with one or a few contexts, but the thing is that they are unmanaged usually. I mean, they have they implement iDisposable usually, so their lifetime scope should be minimal, and so you should dispose them as soon as you're done reading, because if, let's say, we have a database, then it uses up a connection, and we want to minimize the amount of open connections we have. All right, and here you see the implementation of the context, which is just a bunch of in-memory stuff. It would look exactly the same with Entity Framework, exactly the same, except that list would be DB set, and iSchool memory context would be IDB context. And other than that, it would be exactly the same. It does that automatically for you. So you mean that if I inject it, I mean, do you mean through IoC it does that for you? Or you mean that the context itself, that's the behavior context itself? Or the container? Which of the two did you mean? And I will go to program. So you declare constructor parameter for DB context, set up the IoC framework to recognize that it registers is as scoped. Yes. It's a good point about the scope of each of those, because you have a few types of scopes for dependencies. It can be transient, it can be scoped. I actually don't remember all of them, so I'll quickly refer to Unity's manual. So, IoC. Lifetime manager. So we have transient, per resolve, per thread, externally controlled, hierarchical. Those are lifetime managers. Yeah. So we can change the way dependencies behave if they're created once or per every resolve. And by resolve, I mean in order to register the dependencies, we had to call something like this here. Resolve, and magic happens here. And it basically invokes the constructor with the dependencies that we created there. And yeah, all of those that I talk about right now are IoC containers. So here, if I ran something through here, it printed out broken. Now, if I ran something through here, it would print a list of students, the whole school basically. And if I run it here, as you can see, it prints stuff about school. All right, show us what? So this is just basic implementation, and I will show how you can do it. So now by commenting that one, okay, by commenting that one, you basically use the different container, which does essentially the same. And if I do it this, I just want to show that all three work. Right? Right. So now we have 3 IoC containers here, and I will show you their implementations. Let's start with Unity. We already covered. You create a Unity container, which is iUnity container. Well, it implements iUnity container. Then you register dependencies, where the left side is an abstraction and right side is detail. Lastly, we register the root component, the aggregate, the composition basically, that we want to create, and we say we resolve it. So in the end, it through the constructor, which we defined as a component which accepts those 4 types, we created iSchool terminal, a specific school terminal, which is a school terminal registered here. Now, the difference for others is basically non-existent, other than small syntax. Let's go from inject because it's more similar. With inject, very similar, except I don't know why they call it kernel, as it really is just a container. So you create a kernel null. So you create a kernel, and on the left side you have abstraction, on the right side you have implementation. Slight difference is that instead of comma separation, instead of 2 generic arguments, you chain them. So instead of this, you have this. Or actually, why didn't it say that it's a mistake? What does this translate to? Is this the same? Okay. Why does this work? I'll quickly try it out then. Exploration. I did not expect this to be valid actually, as it is very ambiguous compared to the other form of doing it. So if I do this, in theory, I don't know what will happen, but we'll see. We use inject. Okay. So it does a completely different thing. So don't mix this with Unity, as you need to say what do you bind it to. I don't know what the other thing does, but it's different. All right? So that's an inject. And then in the end, you just say kernel get, just like Unity container resolve. And lastly, we have autofuck. And I don't know, all of my colleagues seem to like this one the most, but I personally like this the least because it has one extra step where you need to build a container. Because in all others, you didn't have to like compile and confirm the changes. And another thing that it's really weird, Unity and Ninject has abstraction on the left and then detail on the right, which I also like more. And it's weird to see that the sides are swapped for autofac. So it like when I was making implementation, I just copy pasted the code and changed the syntax, but then it wasn't working, and I realized that it had to be swapped with sides. So on the right side we have abstraction, on the left side implementation. And Jonathan said that he likes it best too. It separates configuration versus resolution. It does optimization that makes it very fast regarding performance, except I prefer pure D over all containers. And I also prefer pure D until it gets unbearable, unmanageable. You can always use service locator. So since I said what service locator, like since I mentioned it, service locator is basically a singleton where you have all dependencies instantiated in one place. So I guess we can do a poor man's IoC, which isn't really IoC, but something like it. So service locator would be something like, well, basically what we did at the top, we would have it, here as well. If I go here and do this, it's not really service locator either. Service locator has dependencies exposed and you just get what you need. So if I had more pages or something, more windows, then it would make sense. Yeah, I agree. Public static class service locator, and we say, well, let's just do the same thing and stick to simplicity, which in the end is more simple than what I did. And we take in-memory one. App to, let's just call it app. Yeah, they do. This would be not service locator, but if I want to make this service locator, it would be non-static class with a static instance to itself. Why am I doing this? I don't know. Service locator instance public service locator instance get if instance is non-existent, we create it, and let's define a private constructor. Can someone tell me, does dependency injection, does IoC container resolve private constructors as well? Or does it have to be public? And let's just say public. Well, it would sound weird because you couldn't possibly do it by manually. So just, that would literally mean that the way IOCs work is reflection based. And I think it's not. I hope it's not. So we have instance. And then we have, what do we have? We have static instance. And we have I school terminal. And we say that, say we don't need this, and school terminal is app. And here we say if instance if we do this, and otherwise we just return instance. Instance service locator. Oh, two slashes, underscores. Okay. So what did you say? Service locators suck. Yes, they do. IOC containers are reflection based. Okay. Yeah. If you register Lambda or factory methods in a D container, those won't use reflection. Only if you register types without explicitly calling a constructor. Okay. The power of ReSharper, behold the simplicity. Okay, so we have a terminal here as a service locator dependency. So now we can do something like service locator.instance.terminal, and it should do the same. So my app is service locator. That's my terminal, and we'll say print info. Did we miss something? We did not. So the same thing done in basically 1, 2, well, this one is different implementation. So 1, 2, 3 different ways, essentially. I count those 3 as the same way. All right. So this is dependency inversion principle and inversion of control implementation, how you can use IOC container to handle dependencies for you. Now, why do we need dependency injection? Why do we need to invert dependencies? Well, consider that suddenly we want to work with a file, or we want to test this. And right now, for example, we have a database call, but we actually need in-memory stuff. We want to test stuff. And in order to be able to test it, we need to have a mechanism how we escape the dependencies that we have defined in our components, in our higher level components, lower level components. It doesn't matter. It's dependencies that we need to escape, to handle somehow. And if we don't expose a way to do so, like we did in here, we will end up being stuck with what we have. So for example, if I wanted to test school terminal without calling database, but school terminal was all database calls, I would have to inject a different thing. I can still use school terminal, but pass in different dependencies. Right now it uses in-memory stuff. So, but I also have not in-memory stuff. I have a reading from file. Well, it's not working. It will throw not implement exception, but it's a different dependency altogether, and I can register it. So if I head to, let's say my terminal, and I say that I want not in-memory stuff, but files repository, I will now be able to call different implementation. Since those, now you see it says not implemented. All it took me is to change a few lines of code, and I completely changed the flow of application, as it now uses files to read stuff from for the school. Different way. If I had actual implementations here, it would be different. I mean, it's already different, but it could show the same thing if I serialized and then just displayed. Let's see. Outside in TDD for the win. Yes. So if I wanted to do something like completely different, and let's say just hook this, this is .NET or .NET Core? Core, okay. So if I wanted to, let's say, test something from that one. Repository, school context, school terminal tests. I would now have my own context where I manage stuff. This is n unit, and we don't need attributes here. Public void test, let's say. Again, I can do the same thing and, or not the same thing. I can say IoC Unity configuration. To reference lesson playground, yes please. Setup. Sure. And I say var. Well, it's a bit different thing now because I have something that I need to test. all of my components were private, but I still need to test them. And so I would need to mock the components and inject the mocks to the repository, to this one. What could I do? Mock it. I could use mock-q, I could create them manually and then set up. Well, I still need mock-q to hook to their calls. Yeah. What would you do with delegates, by the way? Because I'm not aware of how would you test something with delegates in this scenario. Delegates would be private as well, wouldn't they? Yeah, we mock them anyways. I'll get mock-q. Oh, that's what you meant. So, now we need to do some testing, and if we didn't have dependencies exposed through through interfaces, through a constructor, we would end up being stuck with them and wouldn't have a way to escape them. What if we just want to know if the right things were called? What if we don't want to actually call the repositories? I mean, what if we want to call the repositories but not actually do their implementation thing? What if we just want to say if dependencies worked as they intended? Because that's a valid use case, and that happens sometimes as well. So I will copy this and put it, let's say here, to another class. Yeah, sure. Move it another. Why doesn't it want to move to another class? Because it's nested. Okay. Dependencies, yes, please. I want in-memory stuff. No, I don't want in-memory stuff. I want my own stuff. So now I'll do a different thing. So what I want is to create a mock of type T. Mock repository. And what I want to do with it, I want to don't kill me for using activator, please. I know it's bad, but I don't remember syntax for compiled lambda expressions. And T, where T is class, and it implements a repository. Oh crap, it's generic. So it will be a generic repository with, yeah, a generic repository. t with uint as a key, and I'm lost. Mock t. Well, I don't want those at all, but I want to test this. Use the container as a service locator in your tests. Swap out the stuff you want to mock with mocks. Yeah, I can, but the thing is, I don't remember the syntax, how you resolve with a specific instance, how you inject a specific instance. Inject a specific thing. That's why I moved to manual injection, because I want to manually create the mocks and then inject them. Register structure injection. Or is it register instance? Maybe in Unity it's a bit more clear. Is there a register instance method? Register instance. Okay, so we will do it that way then. Unity configuration. Service locator. Here. Okay. Get the fuck out. And here we'll say private static. Yes, like this. And this can actually be test fixture. Test fixture, was it? No. Setup, I don't remember the, yeah, setup. Each test is run setup once, one time setup. Okay. And here we say private iSchool terminal. Right? Whoops. Okay. We will create those separately. Right? We have a terminal. And we say that in our setup we create it. So end result should be void setup, that we do this. And okay, now we have this and all good. Now we need to do the mocking. So mock t build mock, and we pass nothing, and we say that our t is a class. Actually, it's a repository. We know for sure that's a repository. Now I'll just make, it's not repository, it's iRepository. And it's d-uint. Now, why is it picking on me still? Must be reference type. Okay. 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 So the mock would be like this. Type of type iRepository. Oh, it is iRepository. Where T is class, that's all. And we return repository, iRepository T. And that's, of course, thinking how to make this work. Maybe I cannot make generic mocking. Cannot think of it right now. Anyways, maybe someone has an idea how to make this generic? Or should I just school? Well, I don't need to mock this, but I need to mock this. Oh god, I don't remember mock syntax. Setup. Okay. Returns, throws, verifiable. God damn it, don't remember the syntax. Setup, get. Come on, okay, I'll Google. Returns. I don't want to check if it returns anything. I just want to see if it was called once or twice or something. Oh, it's setup because it's... Oh, I'm stupid. Setup just yeah. Returns new list of... what is it? Teachers. Verifiable. Models. Yeah, model. Setup, not setup. Verify, that's the one. Times once once exactly 1. Okay. Then after running this sut, call verify on the mock. Yeah. I think this is not needed at all. All I care is if it was called. And this is teachers repo mock and we have 4 of those. Teachers, students, grades, and lessons. Okay. Teachers, students, grades, and lessons. And good. And now we don't do register type, but register instance. Okay. And okay. All except first one, I think. Okay. Oops. Type. Okay. And instance. The syntax as follows, and we have teachers repo mock. It's not assignable because it has to be an object. And we do the same with others. Then we have grades repo mock object. Then we have lessons repo mock object, and we have students repository mock object. Now that we have this done, we don't need this, and that's our setup. Basically, we created a terminal with mocked dependencies of repositories. So now we say terminal.print info, and let's break it. Will it be green or will it not? 0 times. Why was it 0 times? Oh God. True. So I need to keep reference to the mocks. Okay. Okay. Yes, mocks. This one in my test for now. In a field and resolve the mocks back from that. container in a field. Okay, and resolve the mocks back from that. So you mean container in a field and resolve the mocks from that. And what about the terminal? As I need to okay. Okay, container. I still don't get how do I get back to the mocks that I created to verify them in this case. Setup, do it, but those are not here. Teacher, student, grades, lessons. We should resolve it again. Okay. Isn't this a bit performance crappy to call this for every test? Let's say, well, maybe not, I don't know. Well, I understand that I should mock this in a test. So for every test, I should have a bunch of those? Like basically this a similar setup for every test? Okay. I prefer this as well because it's a bit derp to have container as just one you're testing. So we resolve to teachers repository. So what is the final suggestion for this? I'm not getting the best way of doing this. Okay. So you're saying I should just mock the repositories and feed them to the terminal. Yeah, okay. So we put it here, then we say teachers repo verify. Okay, so we create a terminal. Terminal which takes in students, teachers, then grades and lessons. Lessons repo. Okay. Terminal print, and we're done. Run. We have an extra bracket. Okay, good. It actually printed. So since we didn't have anything there, didn't crash, it called those that it should have and printed. We verified and it was true. So now if I had to refactor this, so what do you mean I could refactor here? Because I don't really see parts that could be moved away in this case. Yeah, okay. So now I would like to go back to the repository implementations. You'd refactor if you add another test and see that the setup is almost entirely the same. And I understand that I would see that, but we need different instances of those mocks. We cannot share the instances of mocks. But we do create new mocks. So I see where you're heading. Basically create the same mocks, recreate them, and add extra stuff. Yeah, okay. So now I just wanted to show you guys how my repository looks like. I used a generic repository. So my generic repository just accepts two things as generic parameters basically. It's a model and a key ID of some sort. And CRUD essentially accepts a model or a key and returns a model or nothing. And I didn't put iCurable here because it's debatable, but I would only put this if I knew for sure it was Entity Framework, so that I can query something simple and make it more complex by applying my own specification. I didn't need this, that's why it's just IEnumerable here. Now, each repository is minimal, as it just specifies with what specific types it works with. So I basically inherit a generic interface, which is types I specify here. Thank you for using enumerable here. Okay. Are you also of same opinion that iCurable is not so good in general? Because, I mean, it should be simple and not complex to query stuff. So we shouldn't filter afterwards, so it beats the purpose to use it. And so we have teachers repository, students repository, lessons repository, all the same except you have a different generic argument passed to it. And we have iEntity because all entities share ID of the same type. Yeah. Could you share why you don't like generic repositories? Because I heard this from other people and I kind of shared the same thing, but in my case, it worked very well actually. Because you see, if I go here, I have generic repository, which basically has one class, and this includes mapping and doing the CRUD for all the entities I need. Yeah. So, how does it work? The thing about repositories is that you shouldn't be working with entities and returning entities unless you really are lazy. What you should be working with, you should be working with your domain models. And so my models are here. Here I have domain models. Those are just plain old, simple CLR objects, POCOs in other words, which hold data the way they're supposed to hold, and some behavior maybe, like to print, to string, and stuff like that. That's what they do. But for my domain, specific to domain. Now in repository, I have entities which are bound to maybe a framework, but the point of those is that they are specifically designed to ease the data transfer from or to database or other data source. And so I have my repository, and the thing I pass to repository is two things. I pass the entity and to which model the entity maps. And so here, when I create something, I pass in a model, but my repositories work with entities. So I need to convert this model into entity that my repository can consume. Okay, let's read what you said. Because you're essentially creating a facade of a functionality given to you by Curably, except this facade is more limited, doesn't expose the same functionality, doesn't offer anything new. Generic repositories require you to constrain your model to fit your repository rather than to fit your domain. And you can leverage memory-backed constraint. Yeah, I agree. But sometimes, I mean, there are cases where it's really useful. Yeah, that is a good point. But for example, what if your domain really does support deletion of entity based on ID? I mean, you have to delete it. Your repository has to delete an entity by ID. Is it really bad to have iEntity, which holds the ID? And well, that would essentially be it. Right now I have a list, but instead of a list, it would be a DB set here instead of list, it would be dbset here. Well, then I probably wouldn't be using generic repository for that one, unless all of them are so unique and specific in their own way. My point of view about generic repositories is that it's not hard to refactor them. And it really speeds up the process of developing it, as you basically write one class, like I did here, which handles all those general cases. And then when it specializes, you can split that one and just implement it. Because if you look at my specific repository implementations, it's barely anything there. It's just specifying which context to use, which DB set or list to consume from a generic repository. So you see that grade repository targets grade mapping from entities grade to model grade, and it uses iSchool memory context to specify that the context I use is grades. But what if there are certain models that should never be deleted? Solid principles from clean code specifically specified interface segregation principle speaks quite well, by the way. Yes. What I have here, then, a very well said point. I think interface segregation is the most valid point here, because by having a generic repository like this one, I say basically that all repositories can create, update, delete, and read, even though they might not. And upon publishing this interface, iRepository, I will be pretty much stuck with it and will have to work around or live with it. Anyways, so what I do in operations with this repository, I map to the entity I need. And I do this with AutoMapper. An AutoMapper looks very simple. You basically create configuration and then you say that this entity maps to this entity. In other words, this class maps to this class maps to this class, and that's it. It suits very well generic repository because AutoMapper is generic itself. I understand this. Yeah, I understand your point. And so in the end, you create the mapper, which you use to apply the mappings in this repository. So why do we need to map stuff from essentially the same entity that we have here and the same entity that we have here? Well, because this is our domain entity and this is our database entity. This can have data annotations like primary key or foreign key or max length, and then you specify something and so on. It's allowed to be here and it should be here. But if I put same things here, I couple my models with unnecessary dependencies from data annotations, from entity framework, and so on. So I cannot really do this in here because I want this to be plain, stupid, simple as possible. Because that's what everything else will consume. So I want to put a big boundary between repository and the models. And then a big boundary between my application and the rest of the logic. And by putting a boundary, I don't necessarily mean just an interface. I mean that all the dependencies, all the uses will travel one directional. So my application will depend on repository and models, my repository will depend on models. And that's what I mean by one-directional boundaries. So that's how I implemented generic repository. And the thing about this is I defined what my repository does. Interfaces here. And I basically implemented it in a file, let's say, if I wanted to read in a file. You want that to be plain and simple because my ORM prefers it, and completely agree it's a great separation of concern. It's data persistence model. Yes. And if you want to go even further with it, what I have here would be specialized for each view. For example, maybe a grade will have a page of its own. Maybe it will be merged with a student. So it should be divided into what is just needed for a specific use case. And it should be specialized to either display, let's say, just datetime, evaluation, and student ID without a note. Maybe that's not needed. Well, it's up to specification to dictate the rules. But by separating entities, which we use to get data, and models, which we use to operate with in our domain, in our application, we are free to do whatever we want with them. So it's useful. So the whole point of dependency injection is to have a way of modifying, extending stuff from the outside. If I hard-coded those dependencies, I would be stuck. If I look at my tests here, I wouldn't be able to test it. I wouldn't be able to mock it because there would be no mechanism to pass those dependencies as a part of school terminal. So by exposing them in constructor, I can pass them. So other ways of achieving this is by having a method injection. So instead I could have passed all those dependencies in here. And this is called method injection. So when I print info, I pass repositories. This is a more rare case, and in my case, it definitely doesn't make sense, because why do I need to pass all those dependencies for a single call or a few calls? I have a state which I need to manage and maintain, and it suits very well within a constructor instead. Lastly, if I made all those dependencies public, that would mean they are injectable through a property. Well, if it was a property. But again, the problem is that we don't want to expose internals, and we don't really want to say what school terminal is made of. We just want to use it. Use it without caring what is inside. We don't want to bother our head with what is inside of it. And I hope that I managed to make a point that dependency inversion principle is not just for cases where you have multiple implementations. Dependency inversion principle is important. Well, interfaces are important for, first and foremost, the reason of escaping dependencies, of being dependent on a concept rather than a specific detail. And interfaces are not only useful for having multiple implementations. That's a really lame and old-fashioned thinking. Interfaces are much more powerful than that, and much more useful than that. If you want to make your code testable or extensible, if you wanted to confirm to open-close principle, to solid principles, other solid principles, it needs to be robust and extensible, and its dependencies need to be exposed from the outside in some way so that you can change them as you wish. If I'm working with my own project, and if I don't write tests, and if I won't expose my code to the public, I think it's perfectly fine not to write an interface, because you won't need it. You won't utilize it. But if you want to make your code testable, and if you want to expose it to the public, you must make sure that you provide mechanisms how somebody else will use your code, how should they escape the dependencies that you defined. By programming to an interface rather than to a detail, you're free to do whatever you want. And so if I wanted to, I could have mocked just one of those dependencies. I could have used a file for one of the repositories instead of a in-memory database. I could have done many things. And yes, but I mean, if you have a property, a public property for an interface, I think that's kind of exposing it. Of course, it's not exposing specifically what is registered under the hood, but it's still exposing that that thing is a part of some composition. I think you shouldn't be bothered with it. So if I didn't have this as an as exposed via interfaces in the constructor, I wouldn't be able to have mocked it, and I wouldn't be have able to test it. So my conclusion to this is that if you are planning to write tests, you'll end up needing dependency injection for sure, because code will be untestable. And they already have that. Yeah. So I would also like to mention, so if we summarize what is a dependency inversion principle, it says high-level modules, and this is high-level module. This is high-level module too. It says it shouldn't depend on low-level modules. What is a low-level module? All of our repositories are lower-level modules. It's a detail. So this detail should not influence our high-level program. And dependency inversion principle says that both of them should depend on abstractions. And our program depends on iSchool terminal, and all we know about it is that it can print info. And then the detail that specific iSchool terminal knows about, the low-level things, are also conforming to different interfaces, but interfaces nevertheless. So we think in concepts and we don't bother how it works. If it breaks, we swap it, we fix it easily. And so each depends on abstraction. And since each depends on abstractions, which are exposed to the outside, we can swap those abstractions. And feel free to do whatever we want. If a part or the whole implementation is not what we like, we can change at will. And the whole point of IoC, inversion of control, is to not do a primitive, like some would say, dependency injection to our application. We don't have to end up creating dependencies ourselves, and instead we can use a different component which can be responsible for creating those dependencies, like we did in here with those three. So we can use inversion of control container, which has a very specific responsibility to just escape the dependencies and register those dependencies, to just register dependencies and set up our initial application. For simple programs, it's not that useful, but for complex enterprise level applications, this is something that you won't do away without, as it simplifies away and makes it consistently using the same dependencies that you registered. So a lot of control, and it is all in one place rather than scattered all across. Note that I didn't make a service locator or a static container, kernel, or whatever you call it in here. And this is because it's not supposed to be used all across application. When we were writing tests, I also didn't like the idea that we considered having this container called for every test to resolve dependencies, because it should happen only once. It should happen only once because that's how, because it is not a light component. It takes a decent amount of performance to work, and so it should be treated with great care. And with great care, I mean once in your application. When it starts, you set it up. Can someone tell me what IoC container does .NET use by default in, let's say, MVC? And that too. Okay. And also one more final note. Jonathan said that he doesn't really like IoC containers, and I agree with him. Oh, okay. And I agree with him. I also don't like them. But when you have a framework, and when that framework comes with a whole package of dependencies, and I'm talking about MVC, ASP.NET MVC, which registers MVC as a dependency and injects it, you should use IoC container which comes with the framework, and you shouldn't be afraid to use what they offer. I understand that you have an option to choose when you're working on your own personal projects, when you're not relying on a framework maybe, but when framework offers it, you should accept it, because that's the way it was meant to be used and consumed. So that is my final point for this. And I think that is all that I wanted to say. I will make some slides out of this to make analogies with images and more focused examples of how it can be done. Yeah. So thank you all for your attention, and see you next time. Bye bye.